So today we are going to hit hard the idea of loops, those blocks that let us revisit code, because those are cool and let us do fun things, and that will culminate in us making a game for ourselves. That'll be very exciting. So without any further ado, let's get started. So loops again, just the idea of like I have some code, it's running like A, then B, then C runs, and the idea of a loop is that you can come back to previous blocks, previous code, and rerun ABC, maybe a million times if you wanted to, all right? And so there's a bunch of different blocks in Scratch that let you do this looping. One that we looked at before, if I go to Scratch, this is all the orange stuff, right? Some of the orange things, at least. It was repeat. Well, there's a few blocks that loop. There's a repeat a certain number of times blocks, and that's the one we studied. We used that before. All right. So this one, if I draw it with ink, so that we have it. What does that look like, and what does it do? So it's like a repeat blank times block, and then you can put a number in here. Put a number in here. You could put a variable in there either. Also, if it has some number in it, and just the stuff inside of that block, you can put as many as you'd want. It can all be run that many times. So this little bit, whatever you put in here, however many blocks you do, it gets repeated n times, and the fancy word for the inner part of a loop, or even for one of those if blocks, like the blocks that accept blocks inside of them, that's called the body of it. All right, so we call this the body of the loop. Body, and that's the thing that's getting repeated n times. Right? It's repeated n times, and that's the technical term. I guess you think of your loop or your like your if block as like a person, and so like the head of it is like the number, and then like the meat, what's really going on, is we call it the body, I guess. Okay, so that's maybe why we say that, but that's called the body, and that's going to get repeated. All right, so yeah. In general, a loop is just a block, keeps getting run. You can tell Scratch how many times you want that loop to run, how many times you want it to repeat its body, or you can just say, like, do your stuff forever until the end of time. That's a thing. That's an option. There is a forever loop block. Forever. And it's, of course, going to run its body until the end of time, just looping and looping and looping, keeping running those pieces. Right? So the inside of it's called the body, and it repeatedly runs, and each time it runs whatever in the body, we call that an iteration of the loop, right? Sorry for all the terms, but that's just the Latin root that means to go, right? It's going through the loop once. So an iteration is just you running the body of the loop once, and so we say that loops iterate. That's the verb form of it, okay? And then there's many more. There's the repeat, got your forever block that forever does something inside of it, and then there's one more looping block. It's this one. Repeat until. This one's interesting. And notice how they have a little diagram, a little arrow to tell you that, yeah, it's going to go back to the start and repeat, potentially. Okay? This repeat until is very interesting. This one's the most general, the most powerful. It takes a pointy thing. It says repeat until something becomes true. All right? So we'll think about that. So let me draw that, just so that we have them all on paper. But yeah, this is our last kind of loop. It's a repeat until, and it takes a pointy thing, so a Boolean is what it takes. A Boolean value, something that becomes true or false, right? And that's our condition, just like for our if blocks. That's our conditional cond, and it's going to repeat all of the body of that loop until that condition becomes true. So it's like starts out false, keeps running while it's false, but eventually it becomes true. Repeat until it's true. Repeat until the condition is true. And so I guess what you put in the body of this loop will eventually cause that condition to become true. So it's like it's messing with the universe somehow. Like it's false, 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 but like whatever you put here is going to eventually make it true, and I'll show you what that means. Okay, but those are all the loops. I hope they make at least a little bit of sense. Repeat until is the fanciest one. We'll have to study that one. But I think I'm ready for an example. Are we ready for that example too? All right, so I just want to make, let's use the forever block, because that's a fun one. Let's just have the Scratch Cat bounce around on the screen forever. I think that will be interesting. Do we want to give him a backdrop? I don't know. Where is he going to bounce around forever? In the sky. There he goes. Cool. I'll call him Scratch Cat. He deserves a name. So I just want this forever block, and let's have the program start when the green flag is clicked. All right, so when the green flag is clicked forever, what do I want the Scratch Cat to do? What do I want to put in the body here and have repeated? Well, I want the Scratch Cat to move and just like keep moving. So if I say move 10 steps, that's a block that runs once normally. It's just like in your current direction, move 10 steps. If you click it, if I put that in the forever block, what do you think is going to happen when I run the program? Imagine it in your mind. Let's see if it's true. Whee! And then you get stuck in the right because you can't go out of bounds in the program. So it's still running. You see it's highlighted. It's not going to stop until you click the stop sign because like forever means forever until you unplug your computer. Okay, does that make sense? Questions about that? So, yeah, it would be cool though to when the Scratch Cat gets to the edge to have him bounce off. And there's a block for that. Did you find it already? Keep on scrolling. It's this one. It's if on edge bounce. So that's kind of neat. So like if he was coming up here, and he hits the edge, it will notice that. This block would notice that and like change his direction to go in the opposite way, like the bouncing way. See it? So kind of this is what I want to repeat. Like move a little bit because it's a repetition of this. Like move a tiny bit, and then if you're on the edge, bounce off. Move a tiny bit if you're on the edge, bounce off. Move a tiny bit if you're on the edge, bounce off. But usually you're not on the edge. But eventually, look at him. He did it. If you're on the edge, he bounced off. So both of these things running together gives us what we want. And so if we do that forever, he's just going to go left and right because he was like perfectly 90 degrees. And so he's bouncing off the edge that way. But if we gave him a different starting direction, shoot him off up here somewhere, then he's going to start bouncing off the corners. Whee! Look at him go. But does this combination of code make sense to us? Like forever, run this stuff, move a tiny chunk of steps, 10 steps in your current direction, and if you're ever on the edge, bounce off that edge. Usually, this block does not run, right? It does nothing. It has no effect until it hits the edge. Okay? Any questions about that? Does that make sense? It's a loop. It's repeating that code. It's better than having to like put it a million times to have this continue so long. Like who knows how many times it's run this for since then. Maybe like at least 1,000 or something. Who knows? So that's useful. That's fun. Okay, so here I'll save this so that you have it later. So that's one example of a loop. I got plenty more. Let's do some math. Sorry, but computers were invented to do math, and this is going to help us understand variables better anyway. So let's make a program that unfortunately will not produce any animation. What I'd like to do is sum up the numbers from 1 to 10 using a loop. Okay? And so what I want is to use variables to perform this task. So I want to make a variable that's going to eventually hold the sum of all the numbers from 1 to 10, because we're going to try to calculate that. Like we're going to add in 1, then 2, then 3 into somewhere. And that somewhere can be a sum variable. So if I start that at 0 and I like add 1 into it, add 2 into it, add 3 into it, eventually it will hold the right answer. That's what I'd like to do. And yeah, that's pretty much the name of the game. I want to start a sum variable off at 0, add 1 into it, add 2 into it, all the way to add 10 into it. And if you think about it, if you squint, all these bullets, right? Add 1, add 2, add 3, all the way to add 10 into the sum variable. They're all pretty much doing the same thing. So that's a repetitive process that we should be able to deal with a loop. So these bullets are repetitive. So that should scream loop eventually in our minds. All right, and that's where we're going with that. And so let's see, what we're going to need to do is we'll need another variable to keep track of like what's the current number right now that I want to put into the sum variable, because like the first number is 1, then it's 2, then it's 3. Let's have somebody keeping track of like what's the current number I want to be adding right now. So that will take a second variable. I'll call it like to add, and I'll start it at 1, right? I'll start it at 1, and then like the first time I'm in the loop, I'll add the to add variable into sum. Now sum holds 1, and then I want to get ready to write back around and have like 2 ready to go into sum, so I'll increment the to add variable. Does that kind of make sense? So I'll make it 2, and then we'll come back, we'll add in whatever to add is into sum again. Okay, now it was 2, so it makes 3. And then increment to add to get ready for adding the next one. You see that if we repeated that process, it would add the 3 in, the 4 in, the 5 in, eventually until 10. Any questions about that before I go to code? Because that's an interesting idea. Does it all make sense, the recipe? Do yell at me. All right. And then, all right, the 3 goes in, make it 6. Now we got to get ready to add 4 in. So we'll add 1 to the to add variable to make 4. Now the right number's sitting in there. Then we'll add in the 4, make it 10, ... until we're done, right? ... Until we hold the right answer, which I think is 55. So that's what I'd like to do. And once it's all finished, once this loop is done, like it's gone through all the numbers up to 10, then in sum, we will have our answer, won't we? Okay. So, are you ready? Let's try it. So I'm going to make a new program. Boop. Sorry, Scratch Cat. And then when the green flag gets clicked, I'm going to do several things. The first things involve variables. All right, so I need 2 variables in this program, a sum variable and a to add variable. You can click to make new variables, or you also get this default one that is called my variable. That's useless. We can right click to rename it if you'd like. Like that one can be the sum. I'll click to make a new one. That can be my to add. That's fine. And if you check these boxes, it kind of shows them on the screen there, which is useful maybe. Remember that. So, okay, what do I want to do in this program? I want to start this sum off at 0. That's what we remembered, right? So at the very start of the program, we should always initialize sum to hold 0. Cool. And then repeatedly, I want to do the following, right? I want to increment sum by whatever is in to add, and the first number I care about adding is 1. So that means the first value of the to add variable should be the one that I want to first put into sum. So I should also set to add to 1. See it? That's what I want to do. What else? So yeah, just like repeatedly now, until the end of time, until I've got to 10, I want to take to add it into sum, increment to add to get ready for the next one. Those 2 things together, a bunch of times. Okay? So how can we make that in code? It's a little weird. It's going to be set sum to whatever it is right now plus to add. So that we have to go to the operators for that. We have to do an addition. Set sum to be whatever it is right now. So sum involving sum, which is a little weird, plus whatever to add is. Does that kind of make sense? It's going to do the math first. So whatever sum is plus to add, shove it into sum. All right, that's the process. And that will add in like the 1, for example. That will put it in here. And then we want to get ready to add in not the 1 anymore, but the 2. So I want to increment to add. All right, increment. And so you could also do like set to add plus 1, or this change block is more simple. I would say it's change to add by 1 adds 1 value, adds 1 number to it. So if you squint and look at to add right there, if I click it, the change block adds 1 to it. Okay. So yeah, here let me click the green flag and we'll just like manually do it. So I click the green flag, to add is 1, sum is 0. And then if I run this block a couple times, I click it to run both of them, it will add in whatever's in to add into sum. So it's like going to be the 1 plus its 0 right now. And then also get ready to have the next number. So change to add by 1. Click. You see how now the sum holds 1, to add is ready to be 2. 2 has not been added in yet, but now we got ready for it. We got ready to add it in the next time we click it. So the next time I click it, and it's going to set sum to be sum plus to add, so it'll make 2 plus 1, 3. So yep, and then the next number that I want to add in is the 3. If I keep doing this, it just added in the 3, now it's 4, just added in the 4, it's ready to make 5. Sorry, it's so small. I can't make that part bigger. Add in the 7, add in the 8, add in the 9, add in the 10. Now 2 add is 11, I don't care about that number. But the sum is 55, and that's the right answer. So does it make sense that if I did this 10 times, I click this block 10 times, it's added on all 10 of those numbers and got the right answer that I care about? Any questions about that? This is very important. So please, as an instructor, I cannot tell if we're shy or if we don't understand. I can't tell the difference. So you guys have to tell me, all right? You have to scream at me. Please do. I'm going to assume things otherwise, and that's not good. So yeah, that is what we want to repeat. And if we just repeat it 10 times, we will get our answer, okay? So we have a nice repeat 10 block right here, don't we? So we just do that 10 times. Just keep on adding your current value into sum and incrementing to add, getting ready for the next one. Just in the blink of an eye, we get 55, and we can have it wait in between, just like to watch it work, like have it click it slowly. So there's the 3 coming in, the 4 going in, now it's 10, 5, 15, 6, 21, 7, 28. Keep going, add in the 9, add in the 10 to make 55, and then it's done. And then the final answer is in the sum variable, so maybe we should say that bigger out loud, like say sum for 2 seconds, something like that. Yeah. Say sum for 2 seconds. And so add in the 1, add in the 3, or sorry, add in the 4, add in the 5, add in the 6, add in the 7, add in the 8, add in the 9, add in the 10. Done. Shout out the answer. That is the program. Are there any questions about this? We good? We seeing it? All right. So, okay. Let's talk about some other things that we could do. Because what I want to do is, let's see. What's the best way to go through this? Notice how that, like we said, repeat 10, that doesn't really generalize very well. Like, what if the user gave us a number? I guess we could put it here, repeat n times or something. I like to teach you the repeat until block now, though. So, let's see here. Let's kind of draw, I think. I don't want to do this. I want to take this code. We're going to change it. All right. So first I want to draw exactly what's happening. I think that would help a little bit. So let's draw exactly how this is working. Boop. So there's the code so far. And all right, let me just run it for you. So set sum to 0 and to add to 1. Sum starts at 0, to add starts at 1. And then, all right, 10 times we're doing the following. We're going to set sum to be whatever it is plus to add. So 0 plus 1 is 1. We're going to shove that into sum. So that is 1. Okay? And then change to add by 1 makes it 2. So now that's 2. Ready to add in the 2. Then we wait a second. And then we just keep on repeating those things. All right, so let's do it again. So, all right, we're back in the loop again because it's the second time. Set sum to be whatever it is right now, plus to add. So 1 plus 2 is 3. Shove that into sum, 3. And then get ready for the next number. That'll make this 3 is the next number I want to add it. Yeah? You see it working? So yeah, let's do that a few more times. I think you can kind of see it now. So then it's going to add in, like 3 plus 3 makes 6. The next number I care about is 4. 6 plus 4 is 10. The next number I care about is 5. ... until it gets to, let's see, the sum is like 45, and like we're on 10 now. This is the 10th time we have to repeat. So set sum to be itself plus to add makes 55. And then change to add by 1 makes 11. Okay? And then it stops. When it stops, we have our final answer in the sum variable. Does that clarify things potentially? So that's what's going on there. And what I'd like to do is teach you the repeat until block. So I guess we have to come up now with a pointy condition that we could put here. Like, I want to keep on repeating these things until something is true. Let's think about this. Like, this keeps going until 11, and then we kind of stop, right? We want to stop. We don't want to add in the 11. That's too late. That's too many numbers. So I say, this is important. I say we stop, right? We want to stop when to add is greater than 10. Yeah? I want to stop when that's true. Okay? Stop when to add is greater than 10, because that was like, I don't want to add in anything bigger than 10. I want to go up to 10. Yeah? So if I repeated this code until to add is greater than 10 is true, that's another way to do this loop. See it? Let's do it that way now. Stop when to add is greater than 10. So I'm going to swap out all this for a repeat until. Boop. And so all this stuff is coming in here. Same. No repeat 10 times. That was too easy. So I want to repeat until to add gets too big. I don't care about it anymore. Repeat until it's bigger than a number I want to put into the sum variable. So repeat until to add is bigger than 10, because 10 is the last number. 10 is the last number I care about adding. And so if it ever gets to be 11, and it will, then I want to stop then. Does that kind of make sense? because that'll be true. Go, go, go. Is 4 greater than 10? No. Is 5 greater than 10? No. Keep adding. Is 6 greater than 10? No. Keep adding. Keep adding. 10 greater than 10? No. Is 11 greater than 10? Yes. It is. And then it stops this loop because it repeats until that's true. Okay? Does it make sense how this is equivalent? A little bit more fancy, but it's more general and for the same reason. All right? So this is the code I care about you studying. All right? That's the better way, I would say. So here. And nothing has changed in this drawing. It's still going to do exactly the same stuff. Like, it's still going to repeat its body 10 times. It's just the way that we checked for did it do it 10 times now involves a comparison. All right? And we can have fancy stuff in there, which is very nice. Okay? So I think with that, I would for sure like to save this. Did I already do that? No. So that you can have it. And then now I have a question for you. All right? So take my code if you have not already done it and put it into Scratch. Go do that. And just get together with the people sitting next to you, say hello, and what I'd like you to do is, instead of adding up 1 to 10 into a variable called sum, I'd like you to add up all of these numbers, 1 plus 3 plus 5 plus 7 plus 9, so all the odd numbers up to and including 25. Does that make sense? So you should be able to change this code to get this. Think about what you need to change and help each other. All right, I'll give you a few minutes to try that, and ask me lots of questions if you have any. Because this code was taken 1, 2, 3 question. Yeah. Oh, yes, so if you check these boxes next to your variables, then you have to like drag them around. Make sure it goes up to 25. Because those are the things you have to change, right? That's the difference. How do you create that difference? Well, what's the same? I guess the similarity is that 1 is still the first number you added. That didn't change. I hear some clicking still, so give us another couple minutes. I'll show you my thoughts. So one hint, if you're still working on it, is I kept track of which number to add in like this, right? It was 1, then 2, then 3, like that, and the to add variable. You somehow want to do, instead of that, 1, then 3 next, then 5 next, then 7, right? Da da da. Those are the numbers you care about. Yeah, until it gets to what? You care about it going all the way to 25, right? 25, 7, all the way to 25, because that's the last number you want to add in, yeah? But you've been counting by 2, so like you want to add in 25, but then once it gets to 27, right, you don't want to add it in anymore. So that should be like the last value it ever has, but you kind of stop everything because of that. That's good timing. So yeah, with that in mind, any brave souls want to tell me some things that they changed? Like what could you, I think if you change 2 things here, you can get it to work. What's one thing that one of us changed? This one? Oh, the change, yeah. So instead of incrementing by 1 each time, increment by 2 each time. Good. Because like that's the first time it's 1, that'll make it 3 next, then 5 after that. Very good. Thank you. There should be one more thing then that needs to change, if you keep it like this at least, that does the right thing. Somebody else, what did you change? What's the other piece? Is it going to go up right now? What's it going to do right now? It's going to go up to, I think it's going to go up to 9, right? Because of this. So once it hits 11, it'll stop. So I think it's that piece that needs to be changed. What do we change it to? What's true when we're done? Yeah, something involving the last number. So this was the to add variable, yeah? We're still using that. Like 25 is good, 1, 3, 5, all the way to 25 is good, but the second becomes bigger than 25, nice, then it's too big. I don't care about any numbers bigger than 25, that needs to stop me. So the second it becomes 27, like notice that 27 is bigger than 25. I do not care about adding that in to this variable, to this sum variable. Does that make sense? Those 2 changes together will give us this answer. And so here, if I change it real quick, go up to 25, change it by 2 each time, you'll watch it slowly but surely count up. 5, add in the 7, add in the 9. A cool fact of adding up odd numbers is it's always a perfect square. 64, 81, 100, 121, 11 squared, 12 squared. So yeah, apparently it's 169. That is the final answer, up to 25. That's, I think, 13 squared, yeah? But that's fun. That's cool. Any questions about that? You see how you can change what I did to get to there. So that's a condition, right? Something that's true or false right now, after it's over, yes, it's for sure true that 27 is bigger than 25, but at the start, when to add was just small and 1, if I stop it now, like to add is only 5 right now, it's not quite true yet. Like 5 is not greater than 25, so it's false. So it keeps on going until it's true. Okay? All right. So yeah, I think that's what I wanted to say about this example. Any questions before I switch gears to a different example? You getting it? Do yell at me. It's not me. I'm here to teach you. So, all right. I would like to get back to other things that involve conditions, right? Let's talk about those if blocks again. I have a fun example, even though it's not the fall semester where there's, I guess Halloween's far away, but I have a silly example that involves ghosts, all right? It'll be like, do you believe in ghosts? And then it will show some ghosts if we say that we do believe in ghosts. So here's what I want to do. Here's my silly idea. I would like to ask the user, like set the scene, graveyard or something, and we'll ask the user if they believe in ghosts. They'll type in yes or no. And if they do believe in ghosts, we're gonna use that to change the value of a variable. It's gonna be called should show ghosts. All right, it's very, very wordy, but it makes sense as to what it should do then, right? Should show ghosts. Maybe it starts at 0 because we're not sure yet. And like we'll set it to a 1, like 0 is false and 1's true, let's say that. Okay, so like if they do believe in ghosts, we'll set this variable to 1. Otherwise, we'll like keep it at 0 or set it back to 0, whatever we want to think about that as. And there's going to be some ghost sprites. All right, that's my silly idea. There's going to be some ghost sprites looking at the value of this variable, just like repeatedly, forever checking it to see if it's changed. And if it's ever a 1, they will show themselves to the believer. Okay, that's going to be the silly example. All right. So yeah, the variable is going to be very important. The ghost just like that's how they get summoned. They're going to watch for its change. If it ever changes, they need to show themselves now. So it's like hiding and showing blocks. That's what we're going to be using. Okay. Does the game plan make sense? It's a silly idea, but it's going to use a variable to keep track of things. And we're going to have a condition, right? An if statement or an if block to check and see like, did it change to a 1 or not? Is that true now? Is it true that it's a 1 now? Stuff like that. Right. So here's the scene when the green flag gets clicked. All right, we need some characters and a backdrop. I think there's like a woods backdrop, scary. There's no graveyard, sadly, but this is scary enough. In the woods at night, and there's the scratch cat, all alone, about to be haunted. All right, so give him his name, Scratch Cat. And then I'm going to add 3 ghost sprites, okay? 3 ghost sprites. So I'll click one, and I think there's 1 ghost. There's like an actual ghost. If you search for it, there is a ghost, and then we have to find some other scary things. Maybe we'll have like a bat, and I think there's a skeleton too. Those are the scariest things I could find before. You can find some others if you would like. Maybe a snake is scary. That's all we get. Where's the skeleton? It should be in order, right? Squirrel. That's funny. So here are my ghosts. Here they are. So scary. All right, and the idea is they're going to be hidden. Like you can change if they're hidden or shown with blocks. And so they're all going to be hidden because we're not sure if the user believes in them yet. But if they say they do believe, then they'll all show themselves to the scratch cat. Okay, that's the name of the game. So I want to use this variable called should show ghost to keep track of that. So let's go down to variables and rename the default one. I'll call it should show ghosts. You can have spaces in your variable names in Scratch, but you cannot have that in any other language. So like in Python that I'm about to teach you, so I'm just like getting you ready for that. So I'm using underscores instead of spaces, though I could have used a space here. All right. So, okay, when the green flag gets clicked, first of all, remember that there's a different program per sprite. So the Scratch Cat has a program here that I could fill in after the green flag is clicked, as well as the ghost, bat, and skeleton. They can all have their own programs that are running when the green flag gets clicked. Yes. So that's something we have to remember from the first programming lecture. All right, what do we got to do now? I would like to, I guess, the first step is to ask the user if they believe in ghosts. Yeah, that's in sensing. Ask, do you believe in ghosts? And wait, all right? And it's then this variable, this should show ghost variable, is going to be set depending on whether they believe or not. And how do we know if they typed yes or no? It's a special answer variable. After they type their answer, if I say yes, then the answer variable holds whatever they gave us. It holds the yes or holds the no. Yeah. So I'm going to be checking the answer variable and using that to set the should show ghosts variable. Okay. If this is yes, this will become a 1. That's my game plan. Okay. That's what I'd like to do. So all right, based on their answer, either it was yes or no, I think that screams if then else block. Yeah. If it was yes, do one thing. If it was no, do another thing. Right. So let's do that. So if their answer was yes, if it was equal to yes, there's an equals to block. So if the answer was equal to yes, then set this should show ghost variable to 1. Yeah, that's what I'd like to do. So set should show ghosts to 1. If they didn't type yes, if this was false, right, they typed no or they somehow misspelled something, I don't know. If the answer wasn't yes, so if this wasn't true, this equality was not true, then we want to set should show ghosts to 0. So we're going to say 1 means they believe, 0 means they don't believe. It's like 1 is true, 0 is false. Right? Does that make sense so far? That's what we're doing. And so if I check the box just for a second so we can see its current value, if I run this program and I type yes and hit enter, it's going to notice like answer holds yes. Is yes equal to yes? For sure it is. So it will run this body of the true branch, yes? Click it. It is 1. It's set should goes to 1 correctly. If I rerun it, if I say no, I don't believe, then it's like, is no equal to yes? Of course it's not. So it goes to the else, right? The false case. And so should show ghost is set to 0 there. So does that make sense how this this answer that we're getting from the user is going to set the should show ghosts variable to either 1 or 0, depending on what they say. We good so far? All right. So with that, now we can do fun stuff. So I think I don't want to check this. That would be silly. What I'd like to do is have the ghosts be like, they should be hidden, right? Start out hidden, 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 hidden. And if the user says that they believe, then they want to wake up and notice that like should show ghost is set to a 1 now. So like let's go to the ghosts program now, for example. Go to him and he can have his own program, right? He can do his own little thing. So when the green flag gets clicked for the ghost, what are the ghost's jobs? They need to be watching this variable. Was it a 1? Was it a 0? If it's a 1, they need to show themselves. If it's a 0, they need to hide themselves. Yeah, that's what they need to do. And like, they just need to be continuously watching this variable, because eventually the scratch cat's going to say I believe and hit enter, and it's like at that split second they should wake up and notice this variable has changed. So forever, these ghosts need to keep checking the value of the should show ghost variable forever. If should show ghosts is set to a 1 now, then show myself. If it's not, don't show myself. So forever keep checking the value of this variable. If it's set to a 1, I need to show myself. That's in looks, right? If it's set to anything other than 1, if this is false, should show ghost is not equal to 1, hide myself. Does that make sense? And you can't just have it as a normal if, because that'll just run instantaneously before the user could even enter in their answer. It's like, all right, it checks it at the very start of the program. We haven't even given our answer yet. That's not good enough. So it has to keep checking it. Keep checking the value forever. Okay? That's what we must do. And so here, let's try it. So if I click the green flag, notice if I switch between the programs, they're both highlighted right now because they're both in their loops. This ghost is repeatedly checking. Should show ghost. It's still 0. Still set to 0. And so it's just like repeatedly hiding itself. Or, sorry, I guess it was 1 to begin with. Let's like initialize it, sorry. Let's say the ghost was hidden to begin with. So I click the green flag. Scratchcat asks this, like we're in the ask block here on the Scratches program. And for the ghost is just stuck in this forever, checking is should ghost set to 1 or not. It is still not, right? It's repeatedly not set to 1, so it keeps on running this hide block. It's like clicking this hide block a million times a second right now. It is not set to 1, okay? But if I say yes, I'm about to hit enter. If I say yes, this will be true. It will set the should show ghost variable to 1, which the ghost is checking for, and then he wakes up and shows himself to the scratch cat. Isn't that cool? Any questions about that? See how that's working? I think that's fun. We do have a bit of an issue with initialization right now. So if I rerun the program, the ghost is still there because he's like still showing himself because should show ghost is still set to 1. So I think at the start of the program, what we should do is make sure that all the ghosts are hidden. And one way to do that, because they're already hooking into this variable, let's just set it to 0 at the very start. Bam. So like ensure, add a comment, make sure the ghosts start hidden. All right, so that's what's going on there. And so like we're using answer to set this variable, and yeah, we just like repeatedly check if the value has changed. That's what we're doing there. All right, so that should do it, at least for the ghosts point of view. So if I click go, set should show ghosts to 0, and so that hid this ghost because like it wasn't 1 anymore. And then if I type no, it just stays hidden. Because like it set it back to 0, it's still 0, I guess. Technically you don't even need this else anymore because you started at 0, but we'll keep it there for fun. And then the ghost just never shows himself. It's just like, all right, show ghost is not 1. I'm never showing myself. I'm gonna keep clicking this hide block on myself. I'm gonna stay hidden. Okay. Any questions about that? It's kind of inefficient because the ghost is like still checking even though the program's kind of over. It's still highlighted. But that's the program for all of the ghosts. And so we want to kind of give this same program to the bat and to the skeleton, because those are my other ghosts that I want to show at the same time. So I want to give this same program to them. An easy way to do that is to take your program and to drag it over to these things. And if you see it just for a split second, it starts to wiggle. The sprite starts to wiggle when you get it over in the right spot. And then once it wiggles, if you just let go, it should copy it there to them. Now the skeleton has it too, so they all have the same, all the ghost sprites have the same program that's looking and figuring out, has the should show ghosts variable changed? If it has, I'm ready. All right, so maybe I'll keep this checked so you can see the change in the variable and how that affects things. All right, if I say no, should show ghost stays 0. Everybody's still watching it, and it's like, all right, I'm still hidden. But if I rerun it and I say yes, then answer was yes, equals yes is true. So they'll set the variable, and they're all watching that variable, and then they wake up and they show themselves. All right? And we're initializing it properly, because if they were all shown at the very start of the program, we're initializing should show goes to 0 to make sure they're hidden, just in case we keep saying no, right? So I think that's what I wanted to say. So if we say yes, they will wake up, and just because they are watching this variable. Any questions about the Scratch Cats program or the Ghosts program, how they're working together? All right, I think that's fun. So yeah, just in general, just to write it down, I did it on the slide. What's going on, right, is I enter my answer, then that changes the answer variable. It's like a big orchestra now. Changes the answer variable, which I can then check. I'll check the answer of the answer variable, and I'll use that to change the should show ghosts, right? And then each ghost is hooking into that variable and keeping track of like, all right, if it's a 0, I'll stay hidden. If it's a 1, I will show myself and stay shown. Like as long as it's a 1, I keep clicking the show block on myself, essentially. Okay, so yeah, I think that was that example. Let me save this for you right now. Just for fun, for extra effect, we can make the ghosts flicker, just to be like, they're kind of there, kind of not there. I think that's kind of cute. So here, to do that, there's an effect that you can have. I think I showed you this already for like transparency. Did I do that already? I can't remember. But it's in, I think, looks. And it's not the color effect. Like here's the color effect on the, oh sorry, let's set the color effect. If I click change the color effect, for example, like it's changing the color of the ghost. That's kind of cool. And if like you can always set it back to 0, the default. But there's a ghost effect, all right? So if you set like a percentage, like 100% ghost means it's like not even there. 50% ghost means it's 50% transparent. 25% ghost means it's 25% transparent. So 75% visible, I guess. So if we just like mess with this, it'll be flickering, right? If I change this rapidly to different values and apply it to the ghost variable or to the ghost sprite, do you see how that would like cause a flickering effect if I just rapidly changed the ghost effect amount to random things? So that's what I want to do here. So to make them flicker, you can do it this way. Change the ghost effect, aptly named here for this example, the ghost effect to a random number And we can get a random number in Scratch. It's nice enough. There's a block for that. So I think it's down here in operators. Yeah, it's just pick random. Pick random from 1 to something. We can change that to be like pick a random number from, I don't know, 25 to 75. It's like a random ghost effect. So it's like somewhat transparent to really transparent. And like every time it runs this little block, it'll pick a random number each time, a different random number. You see it? That's super cool. So like set a ghost effect to a random amount. If I click on this, you see it would do stuff like that if I ran it fast. I'm already running it fast in a forever loop. That's what I want. So like here, stay when you're shown ghost, as long as you want to still be shown, set your ghost effect, please. Does that make sense? Watch it work. Whee! So if I say yes, I believe in ghosts, there it is. It's flickering. It's there and not there at the same time. Maybe it's like, maybe that's what should happen if you say maybe. They're there and not there at the same time. So yeah, what it's doing is just repeatedly, right? Because this is still true. It's always set to 1 for now. And so it's just running these two blocks, making sure it's shown first of all, and then like repeatedly changing that ghost effect to some random number that's different every time because it's random. Does that make sense? That's so cool. I love that. So here, let me copy in the new programs to these sprites. From the ghost, drag it in till it wobbles. Drag it in. And so now they all have it. If I say no, they stay hidden. It's not fun anymore. But if I say yes, look at them. And because it's different every time, it's a different random number for each of them. It's like a different coin flip or whatever, dice roll. They're all flickering in at different rates with different amounts, as fast as the forever block can run those things. I love that. Yeah, I think that's the end of my example. Any last questions about it? Now I want to give you some time to play around. So here, I'll save this so that you can have it. Have the flickers too. But yeah, take my example. Take my ghost example, and I'd like you to mess with it. Just play around. That's how you learn. I think there's plenty of options now. So here, let me give you both of these programs, just in case you don't have them perfectly yet. There's the Scratch Cats program. And you can see it's his program because he's got his little icon up there. And then here's the program of the ghosts. Something like, I think that's visible enough. That's a 75 over there in the corner though. Whee! So there's the two programs that I've made, one for the Scratch Cat, one for every ghost. So you can get to that if you like. And I just want you to play around, talk to each other, say hi, talk about your ideas, and just like make something else in this example. Maybe like make the ghosts all say boo when they show themselves. Could you do that maybe? That would work. You can make them flicker. You can make them, you can mess with this, like these effects are really cool. You can change the colors. Like look into that because that's pretty fancy. Where is that again? It's in looks, right? There's different costumes. You can mess with that. Yeah, really interesting effects like brightness. You can make the ghost glow in the dark. Maybe that might be fun. So, yeah, I think you could have fun with that. Try something. Have them all like shout around. Maybe you can make them fly around. Like I showed you how to do that with the Scratch Cat, right? But pick something and click around and see if you can do what your idea is that you have in your head. All right. And ask me if you have any questions about how to achieve your goals. I will help. But yeah, it's very important to just play around. That's how I learned. On the block too. Look at that. You can make a million ghosts on themselves. Fly around. Give me 3 minutes or so to keep playing. 3 more at least. So I hope you thought of something cool. We can keep playing around. I just have a few more things to talk about. Let's see here. Where am I in my notes? But yeah, just like there is, it's very useful to just do random things and have opportunities to do random things in class. So that forces you to play around. So I hope you enjoyed that. Continue with that after the next 2 slides. So it'll take a little bit to get through this, but I just want to talk about how to make a game now, because essentially we can make a game. So I want to talk about making platformer games. It's like Super Mario. That's what it means to be a platformer game. Like you can run around and like you can jump on platforms. That's why they call it platformers. And so Scratch is perfectly suited to this because it's like 2D. You can go sideways, go up and down. So I want to show you how to just make a simple game in this platformer style. You can jump, have your character move around and jump and stuff, just like Super Mario. So yeah, pretty much all you need is the ability to move horizontally and jump and like interact with the blocks, like the question mark block or whatever. So like we can have that. We can do that in Scratch. It's not too bad. So notice, new program. Notice how Scratch Cat needs a name always. There he goes. Notice how when I move the Scratch Cat, he has a position. There's a coordinate system deep down. Move him to the left, his x coordinate gets smaller. Move him to the right, x coordinate gets bigger. Up increases the y, down decreases the y. As you would expect, he lives in a coordinate system. So if I want to move him with the keyboard, just like, what does it mean to move to the right? Make his x bigger. What does it mean to move to the left? Make his x smaller. What does it mean to make him jump? Make his y bigger. He'll fall by making his y smaller. Does that make sense? That's all you got to do. I mean, the devil is in the details, but like that's more or less the answer. So here, let's do that. Let's do the walking first. That's the simplest. So let's see. So here's my silly idea. First of all, what I want to do is have an underwater scene. So ocean, it's like an underwater scene, and like the cat's like fish, right? So I'll have him walk around and be able to jump up and like catch fish and gain points that way. That's my silly idea of a game right now. So I'm gonna add a fish sprite. And there's different costumes for the fish right now. It looks like Nemo, but you could change that. So like there's the fish, and like I want the Scratch Cat to be down here moving around, being able to get to the fish. So yeah, to give him the ability to move, it's the events, right? Events can hook into key presses. We've seen that. So you got arrow keys. Like when the left arrow key gets pressed, do something. When the right arrow key gets pressed, do something else. And just like we were saying, to move left and right, just like mess with the X and just the X. To move left, that's negative X direction, so make X smaller. I assume that's in motion. Yeah. So you can just like change X by something. Change X by something. When it's left means negative X, so like change the X to be like 10 less than it currently is. Right is fine to be positive. Right? So when I click left, the left key, he's going to move over by 10 units. He's at what? Negative 75 on the X. Click left, now he's at negative 85. And you can hold it in to make him glide. But that's it. You just mess with the coordinate system. Does that make sense? That's pretty cool. He's doing the glide, doing the moonwalk. So that's fun. I love that. Next, we should make him jump. So to jump, that just means increase the Y, right? Mostly increase the Y, because that deals with your up and down motion. So let's have space to jump. That's a common key that means jump in video games. So, all right. Space, when the space key gets pressed, mess with the Y. Change Y by something probably big, right? So like 100, I don't know, we'll play around with this. Change Y by 100 when we click the space bar. Boop. I want to go even more than that, actually. 150. Boop. Let's do 175. So I want him to like get to the fish. Woo, that's perfect. Good enough. So the issue right now is he changed his Y. Click it again. He changes his Y some more. The issue is he needs to fall. Right? Jumps have gravity. We need to be able to fall too. So like this is not the full story for a jump, is it? It's like you do need to warp up there, but you also need to gracefully fall down to the ground. And the way I'll do that is we'll make animation with a loop. Remember this? So remember that loop where I was making the Scratch Cat move around the screen? It was like moving in a little chunk and then looping that. The little chunk creates movement. right? This is a big chunk, that's a warp. But a little chunk, it creates movement. So what I'll do is, I just moved him up 175, or let's like make it easier on ourselves. Let's make it 180. We'll go up by 180 in the Y, and then I want to bring him back down slowly by doing like change Y by like -10. Just like do that a bunch of times. So like if I clicked this 18 times, he'd be moving down. See how that would create animation because it's doing slowly in smaller chunks? That's what I want. So just like repeatedly, to get him back down to where he was, I need to go -180. So like -10, it's going to be 18 times to do that. And that's going to be the answer. So like change the Y, warp him up, when you press space, warp him up straight up to 180, plus 180, whatever he is on his Y, and then repeatedly move him down by 10s each time. That'll create animation because it'll be slow. And then we get that effect. Isn't that cute? Whee! Any questions about that? That's the answer for that. And you see how he's like moving slowly because the repeat block takes some time to run each little change. So it's going to move in chunks of 10, which produces animation rather than just like warping it right back down. Like he just warped up, you wouldn't have seen it. That's not fun. This is more fun. Does that make sense? I love it. So yeah, he can move and he can jump and you can move him while he's falling. That's fine. Those are different events that are firing. Whee, there he goes. So yeah, you get a lot of effects very simply in Scratch. I love it. So yeah, I think what I'd like to do for this game is I would like to like have the Scratch Cat, whenever he touches the fish, is like a coin or something, let's pretend. Whenever he touches the fish, he will like gain a point. He'll collect the fish. All right, that's my goal right now. So here, let's have a variable that keeps track of our current score. So I'll rename the variable to like points or something, call it score. Whatever you want to call it. I'll check it so that it's shown. I guess like we want to zero out the points at the start of the program, so maybe like, I don't know, the fish can be in charge of this. This is the Scratch Cat's doing enough already. So the Scratch Cat's doing movement and things. Let's have another program for the fish. So like when the fish's program starts, we'll click the green flag or whatever. The fish can keep track of how many points we have. So like at the start of the game, we start over again, set points to 0. And then whenever the Scratch Cat is touching the fish, gain a point for the Scratch Cat. So there is a block for that. So this is the fish's program right now. The fish can be in charge of seeing if the Scratch Cat is touching him. So in sensing, there's a neat little block saying, am I touching something? Touching mouse pointer, and you can ask for like edge, and then there's also Scratch Cat. So you can choose another thing, and it's always from the perspective of your current sprites program. So I'm on the fish's program right now. So this is going to give back true or false depending on whether the fish is touching the Scratch Cat. All right, it's different if you did it from the Scratch Cat's side, because then it's from his perspective. So right now, is the fish touching the Scratch Cat? False, no. But if they ever are, like they will be when the Scratch Cat jumps, if I click it again, now they are on top of each other, and it will give back true. See that? So when it's true, we get a point. There's your if. You see it? So that's the answer there. So here, back in the fish, I just want it to repeatedly check because it doesn't know when the Scratch Cat's ever going to hit it. So like forever, fish, keep checking to see if the Scratch Cat is touching you or not. If the Scratch Cat is touching me, what do I want to do? I would like to give the Scratch Cat a point. So I'll change the points by 1. Something like that. Does that make sense? It's like you do have to repeatedly check though, because it's like not now, maybe not now the Scratch Cat is touching me, but like a split second later he will be. Like you have to keep on until the end of time, every split second, seeing, hey, is the Scratch Cat touching me now? Is the Scratch Cat touching me now? Is the Scratch Cat touching me now? That stuff. Okay? Does that make sense? Those kind of checks. So yeah, here if I click it, now it's running. It's in the forever loop. Keep on. It's checking things right now. If I jump, it's still the points is 0. But if I get on top of that fish, woo, it gives me a point. It gives me a point. It gives me a couple points because it just so happens that the Scratch Cat, for a few frames of the animation, he's on top of the fish. Like he's on top of the fish at the top of his jump, and then also for a split second as he's falling. And so he's getting multiple points right now, and that's not good. If I put him up here, he's going to get a lot more points. Just like always touching the fish. See how he gets so many? He's touching the fish for so long. because it's like every time it notices when it's forever loop is going to give him a point. So that's too simple. That's not good enough. He should gain 1 point every time he touches the fish. So here's how we can fix that. What we'll need to do is have the fish stop being touchable the second the scratch cat touches him. The way to do that is to hide it. If you hide the fish, touching will never give back true. So if we hide the fish, the second it notices that the scratch cat touches him, then we can give the scratch cat a point, only 1 point, hide the fish so that you can't give him any more. All right, that'll be the answer. And then kind of the goal is to make it a game. The fish will like teleport to somewhere else, still at the top of the screen though. So keep the fish's y coordinate the same, but like change the x coordinate of the fish. See how that would work? I would move him around horizontally and like show him in that random spot. So like, okay, this is the name of the game now. So here, whenever, this is the fish's program, whenever the fish is touching the scratch cat, give him a point, hide the fish, or as that looks, right? Hide the fish, teleport the fish to somewhere else to keep the game going. Or let's not do that right now for a second. Let's just wait a second before we show the fish again. How about that? We'll work our way up to this. Like, wait a second. So stay hidden for a second. Like hide and then wait a second means stay hidden for a second before you show yourself again. Boop. So he's not moving right now, but at least it'll produce the right thing. So here, the fish's program. You see I touched him. He did all this, right? Whenever I'm touching the scratch cat, I do the following. Give him a point, hide myself, wait a second, and then show myself again. So the fish is hidden for a second, and we get just 1 point because the fish immediately is hidden the second the scratch cat is touching it. Let's move him down a little bit so he's always able to be hit. Does that make sense so far? That's pretty cool. I think the last thing is going to be to make it fun on ourselves. Don't re-show the fish in the same spot. Give the fish a new random spot. So like maybe he's over here, maybe he's over here, but he's along this line, which means his y doesn't change. It's only left and right that changes. So let's have the fish after he's hidden. I want to teleport the fish to be a random x position, like set x to be something random between, what's a good value? So here's like, what, negative 170 to positive 170? How about that? So set your x to a random number between negative 170 and positive 170. See that? So, all right, whenever the scratch cat touches the fish gives him a point, hides, warps to somewhere while hidden, waits a second, and then shows himself in the new spot. Does that make sense how I'm reading that? Can we follow that? I love it. So here, now we're running. Very complicated program the fish has now. So we get a point, and now he's over there. Get a point, now he's over there. So that's decent. Right? That did not take very long. That is a decent game. 4 points, 5 points. There's always only 1 now, which is good. Not getting multiple points every time. That would be wrong. And yeah, randomly appearing in new spots. Not very random right now, is it? There he is. Yay! Beautiful. I think that's the game. Any questions about that? So the scratch cat's just worrying about moving. It's easy enough for him. The fish has all the hard jobs right now. The fish has got to keep track of forever. Every split second, keep checking this because I don't know when the scratch cat's going to hit me or not. Because like you don't know when the user's going to click jump. Keep on. See if the scratch cat's touching me. If he is right now, give me another point. Hide the fish is the fish's program. Hide the fish. Warp to a random spot. Wait a second to show yourself in the new random spot. Boop. Points are 16. Points are 17. And he's moved. Okay? I think that's all that I wanted to show you. I love it. So I'll give you this program for sure. It's a good one to study. Any last questions about any of that? Try it out on your own. Play around with it and make it your own. I think that's everything. So with that, if we are good, I would like to give you your next programming assignment because it's going to be, for those of you doing Scratch assignments, it's going to be with it in the same vein as this. So here's your programming assignment 2. This will be due the 13th, so just a week and a day. here's what I want from you. If you are one of my students who has not programmed before, is doing the Scratch assignments, here's your assignment. I would like you to make a Scratch program very similar to the one that I've done. Right? Looks like I've forgotten to stop attendance. Do attendance if you've forgotten. I'll stop that right as soon as I'm done talking. So, all right, what I want you to do is make a game like this. Make a game where you got a little character. It could be whatever sprite you choose, doesn't matter. Have a character sprite, have the ability to walk with the left and right arrow keys, and jump with the space key. So just similar to what I was doing today, same stuff, same effects. And then what I'd like you to have is to then add something cool, up to you, have something cool happen whenever you touch or jump into another sprite. So like similar to the way that I was doing the fish, but you can't copy me. You have to choose something else. Have a new cool thing that happens in your program when you touch or jump into something. And yeah, I also want you to have at least 2 looping blocks that loop things. So like a forever block counts, a repeat block counts, either kind of the repeat blocks. So those are your hard requirements. Moving and jumping. Something cool happens when you touch into another sprite or jump into it. And then at least 2 looping blocks. All right. And then you can use a lot of what I've given you as a starting off point, but your something cool cannot be the same as mine. Jumping into something I will not give you any credit for that because I already did that. Does that make sense? Come up with your own cool thing. I think that's all that I wanted to say for that. And so yeah, to turn it in, from now on I want a video, right? Give me a video, show me your program working, show me your code, record it however you want, but I want to hear your voice, right? I won't give you credit unless I can hear your voice, you explaining to me that you understand your program that you wrote, all right? So give me the rundown, and then show me how cool it is, play it for a second, and it doesn't have to be long, just like 30 seconds to a minute, that's fine, but I do want to hear you explaining yourself, all right? Prove to me that you understand it. Questions about that? All right. If you are one of my already programmed students doing the racket assignments, let me know if you'd like to do your own custom assignment, by the way. Your next job is these 2 sections of the book and these 3 exercises. All right. So you also, I want a video recording from you and show me your results, the answers for those exercises, and explain your code to me, please. All right. So that's your assignment. Questions about that? All right, let me know if you want a custom one, those of you down here. Getting tired of racket. But I think that's everything that I wanted to say. So yeah, I want to see your cool games. And that's all that I got for the day.